I'm Suzanne and your host for the IEEE EMC Podcast, the podcast to discuss interesting topics on electromagnetic compatibility to our technical community. In this issue, we will talk with Thorsten Schrader. Thorsten is Director and Professor, Head of Division Mechanics and Acoustics at the Physikalisch-Technische Bundesanstalt. We will be talking about EMC signal integrity and on-site measurements. Hi, welcome Thorsten.
Oh, hello Suzanne, welcome.
You work at the PTB. What is the task of the PTB?
Well, PTB is the National Metrology Institute of Germany. And for the American followers, this is comparable to NIST in the US. And in Germany, according to the Units and Time Act, our work is the realization and the dissemination of the physical units. And to realize a physical unit includes the development, the operation, and to maintain national standards. And of course, the dissemination of the physical quantities and the units. And so by this, we do the link between the national metrology, the national standards, and the industry. So industry, there are a lot of requirements for calibration of each devices, like electrical measurements, temperature, whatever, you name it. And so we will do the highest possible measurements, meaning with the lowest uncertainties. So we calibrate the top of the other calibration labs. And then these labs give the calibration to like the workbenches, and then at those you get the calibration of each device. So this is like a pyramid where you see the Metrology Institute being at the top of this pyramid. And then so there are just a few calibrations, and if you go further down, the uncertainty increases more and more, and the number of actually performed calibrations increases by each step. So and at the bottom of the pyramid, then you have the workbench calibrations of each device.
Okay, that's really interesting. And what exactly is your job there?
Well, in the past 15 years, I've been head of the Department of High Frequency and Fields. Yeah, we have dealt a lot of development in the RF metrology, like RF power and antenna measurements and so on. And since May 2020, I'm head of the division Mechanics and Acoustics. So yeah, I think this topic is mainly related to my work being at the Department High Frequency and Fields. And one of my part was the development of antenna metrology.
Mm-hmm. So what was one of the major developments at that department? Yeah,
I think the development of the antenna metrology was really one of the most interesting topics, because we built a large open area test site. We also built a spherical near field scanner. And of course, we developed the on-site metrology.
And how did you get involved with that in on-site metrology?
Yeah, back at that time, we didn't have any instrumentation to characterize like permanently installed antennas, such as instrument landing systems or radar installations on airports. So we had this large open area test site where we could calibrate the EMC antennas for emission testing. And we could also calibrate the communications antennas up to several gigahertz, and we have instrumentation up to 500 gigahertz. But we didn't have any chance to really measure and characterize antennas which are installed permanently on an airport. So there was a strategic decision to develop some sort of on-site measurements, and it may have helped that I fly remote controlled helicopters as a hobby to get used to this on-site metrology, applying drones for the actual measurement task.
Oh wow, that sounds like fun. How did that help with drone operations?
Yeah, well, the flight characteristics of copters are really easy. I mean, this is a no-brainer. When you're used to operate helicopters, which you have to steer in all axes all the time, because otherwise it will crash in seconds, a copter is really simple to steer. If you just don't do anything while the copter is up in air, it stabilizes itself. It keeps its position, and even in windy conditions, it keeps its altitude and also the position. And only if you use the sticks on your remote control, then you can move the copter going forward or backward or whatever. The speed of movement is really much less than that of a helicopter. I think I really got used to the steering of the helicopter, and it was really simple for me to take over the pilotage of a drone.
Okay, I understand. And did you have an evolution in flight measurement platforms?
Oh yeah. Well, I must say we also make use of this stabilization of these copters, because you can also pre-program flight tracks and flight patterns. And of course, in case of failure, you have to be able to control the copter and to bring it safely back to your position. And we did often measurements at military airfields, so you better know what you're doing. And this evolution in flight measurement platforms was really very interesting, because we started with a little quadcopter, but the payload was quite limited. It could not carry larger instrumentation and could not carry a larger set of antennas. So as a consequence, we took the next step and we went to an octocopter. So payload was really greatly improved, and so was flight time, because we could use a larger battery. But much more important, the flight stability of this octocopter, even in harsh and windy conditions, was much better. We had a lot of videos from these on-site measurements where we really have strong winds close to like wind turbines. But this copter really kept its position very nicely. So the next problem is that with this octocopter, it needs the thrust all the time to keep its altitude. And so this is really not very conservative on the battery. And we came up with a third platform, which is now a fixed wing VTOL. And VTOL means it's a vertical takeoff and landing. So that starts as a quadcopter, and up in the air, it can tilt its 4 rotors, and it becomes a real, like a fixed wing aircraft. And the airfoil of these wings are much more energy efficient. So now we can use this measurement platform really nicely from a small spot to start, and then we can use the long flight endurance to take measurements and data on a much longer track in a larger area. So for instance, if you want to see the data change through wind turbines also, you have to have the possibility to measure long flight tracks and also to gather data on a longer time basis, and that really helps.
Mm-hmm. I see. That's quite interesting. And I imagine there are some listeners out there who may as well like to try drone flying. Are these drones commercially available devices?
Yes, the basis was always a commercially available platform, but we improved the whole package according to our needs. So we implemented the shielding and also precision localization with differential GPS, and of course our own measurement instrumentation. And it was also very nice to have the shielding on the octocopter, because it's much easier to do numerical simulations of the antenna installation, because that was really improved by us. And what you also need, what we find out really in the practical application, is you have to have the chance to observe the data validity in real time. So when you are out in the field and when you cannot check the validity of the data, you go home and you see that you forgot to take the data at all. I mean, that happened to us. And then that was the point where we decided, okay, we need to have a real-time check. And now we have a tablet computer where we really get the data downstream, or like say a part of the data downstream, and we can go along in real time. And we can even control the settings of our instrumentation, for instance, like frequency filter settings or attenuation to reduce the signal amplitude or whatever. So yeah, we took a commercially available platform, but we greatly improved this according to our needs.
Mm-hmm. And so regarding EMC, were there any special challenges, such as EMC navigation or integration of antennas?
Yeah, for instance, we wanted to measure like strong radar fields, and you know that there are very high field strength levels in front of radar antennas. So in order to protect the flight electronics and the navigation on board the copter, we had implemented a shielding. And of course, the integration of the antennas was also optimized using numerical simulations. And a very neat thing was that, especially for the VHF copter, the phase center of the VHF antenna matches the center of gravity of the copter. And as a consequence, if the copter moves around up in the air, it still keeps a dipole-like pattern of the antenna mounted on the copter. And this was a nice outcome. So that reduced our own measurement uncertainty a lot. We have designed many kinds of different antennas for the special frequency ranges we are using. And so we spent a lot of energy to really come up with optimization of our whole package.
This sounds challenging as well. So what issues are you working on with on-site measurement technology?
Yeah, at the moment we are involved in experiments to learn about the interaction of wind turbines with terrestrial navigation aids and all kinds of radar installations. And as you mentioned in your foreword, the signal integrity is a very important task. We have the situation in Germany that we need many more sources of renewable energy. So there is the plan to build many more wind turbines. And the problem is that these wind turbines interfere with terrestrial navigation aids like VORs or also radars. And really to learn and to figure out what is the interaction and does it really disturb the functionality of this navigation aid system, we have to do on-site measurements in real setups and with real signals. So, and this on-site technology really helps us to measure signals up in the airspace where it really counts. So where all the real air traffic is going. So for us, it's a really nice support of our work.
Mm-hmm. And are these individual tasks or is this an overarching goal?
Well, at PTB, we started a research focus named Arcas years ago. And Arcas is the abbreviation for Advanced Remote Controlled Sensor Systems. And sensor systems, because of we have developed many different types of sensors in order to really be available to perform measurements on all the different installations. And our measurement capability ranges from 500 kilohertz from non-directional beacons up to 9.3 gigahertz for naval anti-collision radars. And this is a big research focus for us at the moment. And we still get a lot of phone calls and interest from other research groups in our work. And I'm really glad that my successor as head of the department, High Frequency and Fields, carries on these tasks. And the main point is that with our on-site measurements, we can now perform measurements which have not been possible yet. So, for instance, we can measure the tilt down of a radar. So between ground level and like maybe 500 meter. So you can see whether the radar will be able to detect any object due to the reduced field strength close to the ground level. But it's not only the field strength level, but also like front to back ratio of radar antennas, the side lobe levels, and much more. So, for instance, for radars, we are not only taking the pulses, we store each radar pulse, and we can see whether this pulse roof is distorted or not. So we can really figure out the amount of signal integrity or whether signal integrity is given or not.
Mm-hmm. I see. And I see as well that it's a very wide theme. And I'm excited to learn about that in the very near future. Thank you very much, Thorsten, for being my guest today and for sharing your insight on EMC and signal integrity and on-site measurement.
Thank you, Suzanne. So it was my pleasure to talk about that, and I'm looking forward to the upcoming EMC events.
Yes, so if you wish to learn more about wind power and flight safety and EMC, you're very welcome to visit Thorsten's keynote speech at the Joint International IEEE EMC and Signal and Power Integrity Symposium from July 27th to August 13th. For further information, please visit www.emc2021.emcss.org. Thank you for listening to the IEEE EMC Society Podcast. If you wish to learn more about the EMC and receive the latest input from the society and the industry, stay tuned and subscribe to the podcast. I'm wishing you a great day and stay tuned for the next episode of the IEEE EMC Society Podcast.